Hello, everyone, and welcome back to Calculus. So this is our 12th video in Unit 1. And basically what we're going to establish in this video is we want to create some basic derivatives, some sort of very algebraic things that we can work with. What we've had before is this limit definition that lets us calculate f prime of x. But as we've seen, it takes quite a while to calculate f prime of x just using this limit definition. And so what we want to do is we want to build up some tools to be able to calculate f prime of x a bit faster than this. So my first claim to you is if you go through and do this process for a few basic functions, you're going to get some nice things. So in particular, if you calculate that limit definition for taking the derivative of just x to the n, then what I claim is you'll get n times x to the n minus 1. So for example, the derivative of x to the 7th should be bring down the 7, so you'll have 7 times x to the n minus 1 would be 6. So derivative of x to the 7th is 7x to the 6th. Or the derivative of x to the 15th is going to be 15x to the 14th, and so forth. And this will actually also work for integer powers. So for example, if you wanted to do like the derivative of the square root of x, which is really the same as x to the 1/2, you can do the same pattern. So you bring down the 1/2, multiply by x, and then subtract 1 in your power. So you get 1/2 x to the minus 1/2. Okay, so for individual powers of x, we have a nice rule now. In particular, since C, or we could use that, or just we can also look at the derivative of just constant functions. But I claim the derivative of a constant function is 0. So for any constant function, the derivative is 0. So the derivative of the function y equals 7 is going to be 0, and so forth. The next set of basic derivatives that you should memorize is that the derivative of sine is cosine. Then the derivative of cosine is minus sine. This always confuses people. Make sure to sort of keep those separate and which one has the negative sign. I also claim that the derivative of tangent is secant squared. And then e to the x is sort of a favorite of calc students because the derivative of e to the x is just e to the x. And lastly, for today's video anyway, the derivative of natural log of x is 1/x. So these are all sort of our toolkit basic derivatives that we're going to work with. And again, this is really just using that limit definition of our derivatives. So this I claim if you do for each of these functions. So for example, if you are looking at cosine of x, if you take the limit as h goes to 0 of cosine of x plus h, subtract off cosine of x and divide by h, you go through and algebraically manipulate things and use trig identities and all that, what you'll get at the end of the day is that limit equals negative sine of x. So that's how you can get all of these different derivatives. Okay, so that's one set of useful information. The other set of useful information, or the first sort of thing that we're going to have, is you can also combine derivatives. So we have a sum and a difference rule that says if I want to add or subtract two functions and then take the derivative, what I could do is I could take the derivative of the first function and then add or subtract the derivative of the second function. We also have a constant multiple rule, which says that if I want to multiply my function by a constant and then take the derivative, really I could take my constant and multiply it by the derivative. So these are sort of intuitively what we want to work does actually work for these. I will caution you that other things that you're tempted to do, maybe you want to try to do something like a product rule here, saying the derivative of a product is the product of the derivatives. That's not going to work quite as nicely, as we'll see in some of our next videos. But these are the sort of rules that work nicely. Adding and subtracting derivatives works together nicely, and then multiplying a function by a constant works nicely with derivatives. Okay, so let's see all of that actually in practice, or no, sorry. Just a reminder, going back to those last two rules, the sum and difference rule, and then the constant multiple rule, also really just come from applying the limit definition of things. So for example, if you're trying to find the derivative of adding two functions, you just apply the definition to f of x plus g of x, and then you simplify it all down, and you end up getting just f prime of x plus g prime of x. Okay, so now let's see how we're actually going to end up utilizing these. So we have that f of x is equal to x cubed plus 4 cosine of x, and we want to find f prime of x. So f prime of x, I'm saying that's the derivative of x cubed plus 4 cosine of x. And then by the sum law, because I'm adding two functions here, I could break that into the derivative of x cubed plus the derivative of 4 cosine x. Oh, and I should stop and say here, so this notation, I'm not sure that we've used it in a video before. This means take the derivative. So this is take the derivative of x cubed, or take the derivative of 4 cosine x. Okay. So that was coming from the sum rule for derivatives. And then the derivative of x cubed, that's 3x squared by one of our basic derivatives that we had. Since it's x to a power n, we bring down n, and then we subtract 1 from the power that's left. Trying to simplify this down, I don't know the derivative of 4 times cosine x yet, but what I do know is the derivative of cosine x. So I'm going to go ahead and bring that 4 out using the constant rule, constant multiple rule. And then I will be at a place where I actually am looking at a derivative that I know. And so at the end of the day, I'll get 3x squared plus 4, and then the derivative of cosine, was it positive sign or negative sign? It was negative sign, right? So we should actually have minus 4 times sine of x. And so we just found that in general, the derivative f prime of x is equal to 3x squared minus 4 sine of x. We didn't have to touch a single limit, just using our derivative rules and our basic derivatives. So for a second example, we're told that f of x equals 4 times e to the x minus x plus 7, and we want to find f prime of x. So, right, f prime of x says that I need to take the derivative of 4 e to the x minus x plus 7. And I can use the sum and difference rules to break that up into taking the derivative of 4 e to the x, subtracting off the derivative of x, and adding on the derivative of 7. So to do this first derivative, I need to do one more step before I can apply one of my basic derivatives. So I need to bring the 4 out by the constant multiple rule. I'd be left with 4 times the derivative of e to the x. For this derivative, I can use the power rule, right? Because this is x to the first. So I can bring down the 1, and then I'm left with x to the 0. And then this derivative, that's the derivative of a constant function, and we said those were 0. So again, sort of the only rule that I used to go between those lines was the constant multiple rule. Okay. Then we know from our set of basic derivatives that the derivative of e to the x is just e to the x. So we get 4 e to the x. X to the 0 is the same thing as 1. Any number to the 0 is 1. So -1 times 1, I should get -1, and then plus 0. So in total, f prime of x is always equal to 4e to the x minus 1. All right, so it's your turn. Go ahead and try it yourself. So you're told that your function is 6 times natural log of x minus tangent of x. I want you to go ahead and find f prime of x. So pause here and try this problem. All right, hopefully you actually paused and tried that problem. And what you should have gotten is that f prime of x should equal 6 over x minus secant squared of x. All right, that is all for today. Thanks, y'all.